Hello guys, it's me again, double H or H squared if you like. I am your presenter of webline education videos. Right now, in today's video I'm going to be tackling fractions. That's GCSE mathematics fractions, right, where I'm going to be looking at how to add and subtract fractions, and then I'll give you exam type questions as examples which I'm going to solve and talk you through them. I hope by the end of the lesson, guys, you learn how to add and subtract fractions successfully. If you like the videos, guys, please subscribe and leave us a comment there, right, to help us improve on how we present the videos. Okay guys, now let us look at fractions in details. Right, I'm going to talk you through the concepts on fractions, such as adding fractions, subtraction fractions, simplifying fractions, and we're going to look at the fraction war again, just for you to understand why certain concepts when adding and subtracting fractions are the way they are. Those concepts of adding and subtracting fractions can better be explained using the fraction war. Right. Okay, now by the end of the lesson, guys, you should be able to understand what a fraction is, add fractions, subtract fractions, simplify fractions. Okay? Now the knowledge gained from this lesson will help you to solve exam questions such as these, right? Okay, these are typically the type of exam questions that you find in an exam. I'll go back to these questions again, I'll solve them with you, and then give you other questions as well. Now let us look at the fraction war. Yeah. Now, in the previous lessons that I covered in this series of videos, I've talked about the fraction war and how it works. Now, for this lesson, guys, we're going to look at the reason why addition and subtraction of fractions is dependent upon the denominators of the fractions being the same, right? If the denominators of the fractions are different, you've got to do something to make sure that they have the same denominators before you can actually add. And adding of fractions is very simple. As long as the denominators are the same, you simply have to retain the denominator and add the numerators. And the fraction war explains why. You can see half and half there. When you add these two, they should give you 1. And this is how it works out. Half plus half is equal to 2 out of 2, and 2 out of 2 is 2 divided by 2, because which is equal to 1. Now, the denominator here is 2, the denominator here is 2. The denominators are the same, therefore you retain the denominators 2. Then you simply add the numerator. This numerator and the numerator added. 1 plus 1 will give you 2. So you have 2 out of 2, which is equal to 1. Now, please, this is wrong. Right? This is a misconception. You don't have to add the denominators together and the numerators together, because reality does not accept, does not agree. If you add half plus half, it gives you 1. If you add it in this way, you come up with half again. So you can't add half and another half and get half, because 2 out of 4, if you cancel it down, right, simplify this 2 quarters, you simply get half. So half plus half cannot be equal to half. It should be equal to 1, as it says there. That's why it's important to follow this method. Make sure the denominators are the same when adding fractions. You've got 2 there, you've got 2 there, you retain the 2, then you simply add this one to that one, gives you 2. So 2 divided by 2 is equal to 1, which simply agrees. This half and that half gives you 1. The same applies here, guys. Right? You've got a third plus a third plus a third. The denominators are all the same, and therefore you can retain the denominator and add the numerators. So 1 plus 1 plus 1 gives you 3. 3 divided by 3 is equal to 1. This is totally wrong. If you add all the denominators to get 9 and add the numerators to get 3, cancel this fraction down, it gives you a third. There is no way a third plus a third and a third give you a third. That's totally wrong. Okay? This explains why denominators have to be the same before you add or subtract fractions. And subtraction or addition of fractions involves making sure that the denominators are the same, and then you simply retain that denominator and add the numerators. Then you simplify. Then you've added or subtracted your fractions, guys. Now, if the denominators are different, there are methods that you can use to make sure that the fractions end up having the same denominators, and then from there you can proceed to either subtract or add. Okay, I hope that is clear, guys. Now let's move on to another concept. Now let's look at the actual subtraction and addition methods, guys. Right. Now this is the point that I raised earlier on. To add fractions, you need to make sure that denominators are the same. Making denominators the same can be achieved in 2 ways, because most of the questions that they bring in an exam are those that have fractions with different denominators. Right. So what you need to do is, before you can add, you need to make sure that the denominators are the same. Now this can be achieved by 2 methods. Okay, you can achieve that by multiplying or dividing both the numerator and the denominator of the fractions by a suitable number. I'll show you in an example how that works. And then 2, by adding the common, by finding, not adding. And method 2 involves finding the common multiple of the denominators of the fractions involved. Now let us look at method 1. Right, now under method 1, here I'm going to use a multiplication method, right? But I'll show you how to use a division method later on. You have half being added to 2/3, guys. As you can see, the denominators there are different. This one is 2, that one is 3. So you can't add the numerators straight away. You have to make sure that before you add the numerators, you need to make sure these denominators are the same. Now, what trick can we use to make sure that these are the same? As the method says, their multiplication method is what I'm going to use here. So think of a number that when you times this denominator and times that denominator, think of 2 numbers that you can use. You can times this one by that number, times both the numerator and denominator by that number, and you end up having the same denominators. Right. Now, this is very simple. What I tend to do sometimes is simply juxtapose it. Take this 3, multiply the whole of this fraction, multiply the numerator and denominator by this 3, and also multiply this fraction by that 2, which means I'll multiply this 2 by 2 and this 3 by 2. By so doing, I'll end up having same denominators. Okay, this is what happens, guys. So I've taken this 3 and multiplied by the whole of that fraction. That is 1 times 3 and 2 times 3. And I've also taken this 2 and used it to multiply by the whole of that fraction. I've got 2 times 2 and 3 times 2. Now, this will give me 6 and that will give me 6. This is how it works, guys. So I'll have 1 times 3 will give me 3, 2 times 3 will give me 6, 2 times 2 will give me 4, and 3 times 2 will give me 6. So can you see we've moved from different denominators there to same denominators. At this point, now that the denominators are the same, guys, we can simply retain this denominator and add the numerators as follows. Okay? So we have retained the denominator 6 and added 3 and 4 to get what? 7. And then this fraction is an improper fraction. It can be simplified into a mixed fraction, which turns out to be 1 and a 60th. Okay? Now, this is wrong, guys. Like I said earlier on, don't do this. This is totally wrong. You can't add a denominator to that denominator and find 5 and add the numerators like that. That would be totally wrong. I did explain earlier on why this is wrong using the fraction wall. I hope that clarifies the reason why you have to make sure that the denominators are the same before you can add the numerators. Okay? Now, by using the common multiple method, guys, right, this is what you do here. You've got a third, 2/7 taken away from a third. That is 1/3 subtract 2/7. Right. Now, what we have to do here, guys, is we need to find the common multiple. This is not the lowest common multiple. Right? It doesn't matter whether you find the common lowest multiple or not. What matters is just a common multiple, because after you've finished finding the answer, you can simply cancel the fraction down or simplify the fraction. Now, you've got 3 and 7. These are two different denominators. Therefore, you cannot retain either of them as the common denominator and then add the numerators. You can't do that because they are different. So we're going to use common multiple method, guys. Now, under this method, what we do is we think of a number that can be divided by 3 without leaving a remainder, right? We can also divide that number by 7 exactly without leaving a remainder. Now, in this case, that number is 21, right? 21 can be divided by 3 exactly, and 21 can be divided by 7 exactly. Right. Sometimes you can simply multiply these two. Like in this case, it follows. Multiply 3 by 7 to get 21. And then you write that number there, draw the line. Then to get these here, the top numbers, you have to divide 3. You have to divide 3 into 21. You say 21 divided by 3, it gives you 7. 7 multiplied by 1, you get 7. Then you do the same here. How many times does 7 go into 21? It goes in 3 times, because 3 times 7 is 21. So 21 divided by 7 is 3. That's 3 multiplied by 2. You get what? 6. Okay? Then you simply retain the denominator and subtract 6 from 7 to get 1. Right? And that is the correct answer. That is totally wrong, guys. That is wrong. You can't subtract the numerator's right answer, and you can't subtract the denominator's right answer. This does not follow. this is incorrect. Okay? Right guys, now that we've looked at the concepts of how you can add and subtract fractions, it's time for us to look at the actual exam type questions. Right? I'll solve these questions with you, and if you are not following anywhere along the way, guys, just give us a comment and then I can clarify what is happening. Let us go through that very quickly, guys. Show that 5/6 minus 3/4 is equal to 1/12. Okay? As you can see here, the denominators are not the same. Right? So we need to do something to make sure that the denominators are the same. Okay? Now, I'll use the multiplication method because that one looks a bit easier for most of you guys, but you can also solve this one using the common multiple method. Now, what number can I use to multiply this fraction and this fraction so that they end up with the same denominator? Now I'm thinking here, the common denominator that I can have here is 12. Therefore, I need to multiply this fraction by 2 by 2. This one I'll multiply by 3 by 3. Okay? The whole idea here is to end up with the same denominators. So as you can see here, I will have 12. Here I also have 12. Now, whenever you do to the numerator, you must do the same to the denominator. Or whatever you do to the denominator of the fraction, you do the same to the numerator. So if I multiply the denominator by 2, I have to do the same with the numerator. Here, if I multiply the denominator by 3, I have to do the same with the numerator. That retains the value of the fraction. It doesn't change anything. If you don't do it this way, then you're changing the value of the fraction. Okay? So then I'll have 10 there, divided by 12, divided by, this is 9 there, divided by 12. Now that I've got same denominators there, I'm simply going to retain the denominator, draw a line, and then subtract 9 from 10, which is going to give me 1 out of 12. Okay? That is method number 1. Right. Let me try and use method number 2. This is method 1, multiplication method. This is common multiple method. Okay? Under the common multiple method, guys, this is what I'll do. Okay? I'll think of the number that can be divided by 6 and 4 exactly without leaving a remainder. And that number to me is 12. If you divide 12 by 6, you don't get a remainder. If you divide 12 by 4, you don't get a remainder. Therefore, 12 is that number. So I'll write that number there, draw a line on top. And then next thing I'll do is I'll divide this 12 by 6. 12 divided by 6 is 2. Then that 2 is multiplied by the numerator. So it will be 2 times 5. Okay? Minus. Then 12 divided by 4 is 3. So I'll write 3 times that 3, like that. Okay? And then 2 times 5 will give me 10. 3 times 3 will give me 9. All of it divided by 12. You see, we've come back to that. Simplifying that will simply give us 112. So either you use the common multiple method, which is method 2, or use the multiplication method in order to make sure that the denominators are the same. You still arrive at the same answer. Okay? Then number 2, work out the following and give your answer in its simplest form. So what this is asking us is, once we've got the answer, guys, we need to simplify the answer. Okay? Now this is how you do it. 3 out of 8 plus the quarter. Right? I am going to use the multiple method, guys, in this question, but if you like, you can use the multiplication method. So I'm simply going to draw a line there. Yeah, in fact, I can use a multiplication method to make it easier so that people can get used to this idea. 3 out of 8. I'm going to use the multiplication method, guys. Right, now the whole idea here is to make sure that we have the same denominators, right? Let me remove this here. We have to have the same denominators. Now, as you can see, what I'm going to do here is I'm going to multiply the whole of this fraction by 1 and multiply the whole of this fraction by 2, so that 2 times 4 will give me 8. Okay, so this will be 3 times 1, 8 times 1 plus 1 times 2, 4 times 2. Okay, the aim is to get the same denominators. Now remember what I said earlier, whatever you do to the numerator, you do the same to the denominator. Now this 3 times 1 is simply 3, a line. 8 times 1 is simply 8, plus, then 1 times 2 is simply 2, then 4 times 2 will give me 8. Now we've got the same denominators there, guys. We can simply go ahead and add the fractions now, right? Same denominators, we simply have to return the denominator because it's common, it's the same one for both, right? Then we simply add the numerators. That will give us 5 out of 8. Okay. Now, the way the fraction is there, 5 out of 8, you cannot simplify it any further than that, because you cannot find a number that will divide both 5 and 8 exactly without leaving a remainder. There isn't any. There isn't any whole number or any factor that you can use. So therefore the answer in this case is simply 5/8. Now, let's look at number 3. Work out the value of 3 2/5 minus 2 3/7. Give your answer again in the simplest form, which means you simplify the answer. Okay, so this is what we will do, guys. 3 2/5 minus 2 3/7. Now, in this case, there are two methods you can use. You can either, first of all, simplify these mixed fractions into improper fractions, if you like, which I'm not going to do at this point. Probably I should do it, right? I should do it, but I think it's not necessary. But you can do that anyway. I'm going to follow a simple method. So what I'm going to do here, guys, I'm simply going to isolate these whole numbers. I think the best way, guys, is because that one will look a little bit complicated anyway for most of the viewers. So I've decided to gently change all these fractions into improper fractions, and then I can proceed with the same method. So we know how to do that now, guys. 5 times 3 is 15. 15 plus 2, that will give me 17 out of 5, minus. Then this is 2 times 7 is 14. 14 plus 3 will give me 17 out of 7. Now that we've changed the fractions into improper fractions, we can now proceed as normal. Our aim is to make sure that these fractions have the same denominators. Okay? Now, the only number that springs to mind here is 35. Right, now, to get 35 here, 35 there, what do? We can multiply this by 7 and multiply this by 5. Okay? Then whatever we do here, we have to do the same on top. Because we're multiplying by 7 here, we have to multiply by 7. Whatever you do to the denominator, you do the same to the numerator in order to keep the value of the fraction the same. Right. So what we're going to end up having here is 17 times 7 over 35 minus 17 times 5 over 35. Now that you've got the same denominators, guys, you return that denominator because it's common for both sides, for both fractions. Then now you multiply 17 times 7. That one will give us 119. Okay? Minus this one will give us 85. Okay, and then 119 minus 85, you return the denominator, then subtract the 2, you have 4 and 3. Okay, you have 4 and 3. In this case, guys, as you can see, there isn't any way we can simplify this any further because we don't have a factor that can divide 34 and 35 exactly without leaving a remainder. So this is the simplest form. Okay, so going back to the question there, first of all, had to change the mixed fractions into improper fractions and then proceeded as normal to arrive at the answer. The last one, guys, work out the value of 5 minus 2/3. So you've got 5 minus 2/3 there, and give the answer in its simplest form as usual. Right, now in this case you've got a whole number and a fraction, guys. Now this whole number can also be written as a fraction if you can simply divide it by 1. It doesn't change anything. Okay? Dividing any number by 1 is simply that number. 5 divided by 1 will simply be 5. So it doesn't change anything. But for the sake of simplifying your work, you can simply divide this by 1 and make 1 to be the denominator. So you have an improper fraction there and a proper fraction. Then you're subtracting. Then you proceed as normal. Okay? So in this case, since we've got 1 and we've got 3 there, the number that springs to mind that can serve as a common denominator for both fractions is 3. Now, how do you make that one to be 3? Simply by multiplying by 3. And since you're multiplying 1 by 3, you must multiply the numerator by 3 as well. Right? Here, we know we want 3 as the denominator. We simply have to multiply this 2 by 1 and 3 by 1. Because our aim is to get 3 as the common denominator. Now, this goes to simplify into 5 times 3 is 15. 1 times 3 is 3. Minus 2 times 1 is 2. Then 3 times 1 is 3. Now you have the common denominators there, guys. Okay? Because these are common on both, you can retain the denominator there and then subtract the numerators. Now 15 minus 2 gives you 13 divided by 3. The question says in its simplest form. Now this is not the simplest form. The simplest form would be a mixed fraction. Simplest form means you can no longer divide, in essence. But here we can divide. So 13 divided by 3 is equal to 4. Remainder 1, 10 over 3. It's simply converting the improper fraction into a mixed fraction. And if you convert this back into an improper fraction, it will give you that. Okay? Alright guys, thank you for watching the video. This marks the end of this lesson. Please, if you find these videos helpful, subscribe and like the video so that you're notified of the new uploads, guys. Okay? This marks the end of this lesson, guys. See you again in the next video in the series. Guys, if you find this video helpful, please like, share and subscribe to the channel to help us. Tip donations are also welcome, guys. All you have to do is scan the QR code below. Thank you for watching, guys. Looking forward to see you in another video. Thank you.